right, everybody, you need to go ahead and get out 2 highlighters for me, please, if you have not already gotten them. And you need to take this piece of paper and go ahead and highlight your title. So I'm going to highlight my title. Keep in mind through this whole process of circles that if you don't remember the rules, that makes this 100% undoable, because otherwise you're not going to know what to do. So far about circles, we have learned about central angles, inscribed angles, interior angles, and exterior angles. Let's review. I want you to draw an example of each of them. So I want you to pause this video, and I want you to pause, and I want you to label. So we're going to do central angle, and I want you to draw a picture. And then we're going to do an inscribed angle, and I want you to draw a picture. And then we're going to do interior, draw a picture, and then we're going to do exterior. So I want you to pause this video, and I want you to draw a picture of each of these 4 angles. So a central angle starts at the center. What do you know about a central angle? This angle and the corresponding measure are the same. An inscribed angle, what has to be true about that one? Well, the vertex has to be on the circle. What do you know about the angle with its corresponding arc? The angle is half the measure. An interior angle is formed by 2 chords. This angle right here is the same as that angle right there. So how do we find that? Remember, we draw the bow tie. So I would draw my bow tie. And how I would find it, I would take this arc plus that arc divided by 2 to get me the angle measure. And then the last one is an exterior angle. How I would find my exterior angle is I would take my big arc minus my little arc divided by 2, and that would get me my angle. So go ahead and pause this video again, and I want you to solve these 3 problems. When you all finish them, unpause and we'll go over the answers together. Alright, so looking at this one, X, what kind of angle is it? Is it central, inscribed, interior, exterior? Well, it's an interior angle, so I'm going to draw my bow tie. So my bow tie goes like this. So, what's it going to look like? I'm going to do 210 plus 76 divided by 10 equals X. So 210 plus 76 divided by 2, I get 143. So X is 143 degrees. Look at the next one. What kind of angle is it? Well, that's an exterior angle. So if I highlight my piece of pie, look at the crust that it touches. I do my big crust minus my little crust all over 2 equals 35. So I solve for X. Multiply by 2 on both sides. I get 78 minus X equals 70. So I'm going to add X to the other side to make it positive, and I'm going to subtract 70, and I get X equals 8 degrees. Last one. What kind of angle is it? Well, it's an inscribed angle. How I know it's an inscribed angle is because its vertex is on the circle. So I would do 66 divided by 2, so X is 33 degrees. So we have a bunch of theorems with circles, and we've got to make sure we keep them all straight. So hopefully you're all doing okay. So let's go ahead and talk about these next 2 theorems. The first one is an inscribed quadrilateral theorem. What this problem tells me, theorem tells me, when a quadrilateral is inscribed in a circle, opposite angles are supplementary. So what this is telling me is when I have a quadrilateral inscribed in a circle, opposite angles are supplementary. So opposite angles. So angle S and angle Q are opposite, and angle R and angle P are opposite, which means they're supplementary. So angle S plus angle Q equals 180 degrees. And angle P plus angle R also equals 180 degrees. So whenever you have a quadrilateral inside a circle, its opposite angles are supplementary. All right, so now let's talk about an intersecting chord theorem. Notice in this picture, I have two chords. I have this chord here and this chord here. They intersect each other. When my chords intersect each other, the product of its pieces are the same. So when two chords intersect, the product of its pieces are equal. So, what I mean by this, when two chords intersect, the product of its pieces are equal. So notice I have this blue chord right here. It's made up of A and B. So the product, A times B, is equal to the product of my other chord, C times D. So when I have two chords that intersect each other, A times B equals C times D. That's the next theorem. So when two chords intersect, their products are the same. That doesn't mean their lengths are the same. That means when you multiply the pieces together, they're the same. When you find the length, you would add them up, and when you add them up, not necessarily are they the same. So go ahead and flip your paper. Examples. Let's take a look at this. Notice number one. How am I going to solve this? Well, it's my intersecting chords theorem. So this chord intersects this chord. So to set up my equation, I would say 3 times 8 equals x times 4. Piece times piece equals piece times piece. So I have 24 equals 4x. So solve for x. X equals 6. Look at the next one. I have an inscribed quadrilateral. What do I know about inscribed quadrilaterals? Well, opposite angles are supplementary. So if this is 77, how do I find x? Well, I'm just going to take 180 and I'm going to subtract 77. So x is 103 degrees. All right. Let's start talking about tangent theorems. Multiple tangent theorems. Let's do this first one. Tangent theorem. All tangent lines are perpendicular to the radius and diameter. All tangent lines are perpendicular to the radius and the diameter of a circle. So remember, a tangent line is a line that touches my circle in exactly one spot. So here's my tangent line. And here is my radius. And notice my tangent line and my radius are perpendicular, which means they meet at a 90-degree angle. So this theorem's huge because it helps you out a lot. So let's look at some of these examples. It says, how can we use the tangent theorem above in order to help us find the missing measures? So looking at this picture, number one, I want to be able to find x. Well, I know that this line here is tangent, and this line here is tangent, And that must be the center of my circle, which means those must be radii. So that means this has to be 90 degrees and that has to be 90 degrees. So how am I going to find x? Well, I'm just going to add them all up. 119 plus 90 plus x plus 90 has to equal 360 because it's a quadrilateral. So in my calculator, I'm going to do 119 plus 90 plus 90. I get 299 plus x equals 360. So now I'm going to subtract that from 360. And I get x equals 61 degrees. All right, let's look at the next one. Looking at this next one, I know that this line right here is a tangent line, and this must be my diameter. So what do I know about tangent lines and diameters? Well, they're perpendicular, so they form a 90-degree angle. So how am I going to find x? Well, I know all angles in a triangle add up to equal 180. So 43 plus 90 plus x equals 180. So 43 plus 90, I get 133 plus x equals 180. So I'm going to subtract that from 180. So x is 47 degrees. All right. So before we do number 3, I want to do number 4. It says, actually, yes. No, I lied. Let's do 3 first. All right. So I want to find x. I'm going to make this a little bit easier. Actually, no, we're going to leave it as is. So I know x is a tangent line to my circle. So since it's tangent, I know that this is a 90-degree angle. So if this piece of my triangle is x, my radius is 5, this piece right here is 11. How do I find this piece right here? Well, this piece right here is classified as a radius, right? So if this is 5, this also has to be 5. So that also has to be 5. So notice I have a right triangle. How am I going to find x? Pythagorean theorem. So 5 squared plus x squared equals 16 squared. How did I get 16? I added my hypotenuse together. 5 and 11 make 16. So I have 25 plus x squared equals 256. So I'm now going to solve all of this in my calculator. I'm going to subtract 25. I get x squared equals 231. I am now going to square root 231. I get x is 15.2. So looking at number 4, I want you to go ahead and pause this video, and I want you to see if you can figure out what number 4 is going to equal. When you finish, unpause this video, and then we'll go over it together. So to ensure that this triangle, that CB is a tangent line, that means this angle right here has to be a right angle. So how I'm going to ensure it's a right angle is I'm going to do the Pythagorean theorem. So I'm going to do 3 squared plus 12 squared equals 15 squared. Now notice on this problem I did not have to put the 3 right here because my directions told me that OB was 15. It told me the whole thing right here was 15. So I have 9 plus 144 equals 15 times 15 is 225. So 9 plus 144 is 153. Does 153 equal 225? Nope. So is CB a tangent line to the circle? No. Go ahead and flip your paper. Tangent theorem. Highlight it for me, please. Tangent theorem. When two tangent lines intersect, they are congruent. So when two tangent lines intersect, they are congruent. So notice this tangent line, AB, intersects with tangent line BC. When those two tangent lines intersect, they're congruent. So I can put my little tick marks here. So I would say AB is congruent to CB. I call this the party hat theorem because this looks like a party hat that somebody would wear at a party. They're the same length, and this would be my face. Although in reality, this would be my face if I had to wear a party hat. I don't like wearing party hats. So, let's look at these examples. Find x. I know these two lines are tangent lines. So if AB is 15, what's BC? Well, it's 15 because they intersect, and I know it makes a party hat, and my party hat has congruent sides. Look at the next one. It says find the perimeter. Well, how do I find the perimeter? Well, I got to look at all my party hats in this picture. I got to add up all the sides. So I'm going to focus on this party hat first. Here's one party hat. This is a person who's wearing 4 different party hats on their head. So notice if that's 6.2 right here, this also has to be 6.2 because they're the same. So I'm going to fill out 6.2. All right, so now let's look at another party hat. This party hat right here. If that side of the party hat is 4.5, my other side of the party hat is 4.5. So let's now look at another one. This teeny tiny party hat right here. If one side is 1.5, the other side is 1.5. And if I do my last party hat, let's do this color. If one side is 0.75, the other one is 0.75. So, how do I find the perimeter? Add up all the sides. So I will do 4.5 plus 6.2 plus 6.2 plus 0.75 plus 0.75 plus 1.5 plus 1.5 plus 4.5. And I can't type things into my calculator. Hit enter. I should get 25.9. So my perimeter is 25.9. All I did was I took all of these values and I just added them up. These added up, these added up, these added up, and those added up. So go ahead and pause this video and I want you to try solve number 3 on your own. You should have gotten x equals 5 on this. If you need help, all we do is look at party hats. This is a party hat. So if that's 4, this is 4. This is a party hat. If that's 3, that's 3. And if this is a party hat, if that's 2, that's 2. To find all of x, I add it up. 2 plus 3 is 5. Everybody with me? I hope you're doing all right. Let's talk about the tangent secant theorem. Go ahead and highlight tangent secant. When you have a tangent and a secant line, so notice here is my tangent line because it touches my circle once. And here's my secant line because it intersects my circle twice. When you have a tangent and a secant line, here's how I do this. It's a little formula that I memorize. I do my tangent squared equals my outside piece times the whole secant. When I have a tangent and a secant line, how I'm going to solve this is by this formula. Tangent squared, so I take my tangent length and I square it, and that's going to equal my outside piece times my whole secant line. And again, remember, if you don't know this formula right here, this whole thing is impossible. So let's go ahead and look at this. It says PA is 25.4, PC is 21.7, and it says PD is x. So notice I have a tangent and a secant line. So follow this formula. So I'm going to highlight my tangent. My tangent is red. I even highlight it red here, and then I do purple here, so you know. And here's my secant. So my tangent is 25.4. So 25.4 squared, because that's what the formula says, equals my outside piece of my secant. This is the piece that's on the outside of my circle, which is 21.7, times the whole secant line, which is x. So now all I do is solve. So 25.4 squared is 645.16 equals 21.7x. So now I'm going to divide by 21.7. Oops. I get 29.7, so x is 29.7. All right, excellent. Let's go ahead and let's keep going. Next one, I'm going to highlight my tangent line. I'm now going to highlight my secant line. So set up the formula. PA, which is my tangent line, so tangent squared equals the outside piece of my secant, so this is the outside piece, which is 21.7, times the whole secant line, PD, which tells me down here is 32.6. So I have x squared equals 21.7 times 32.6, which is 707.42. So now how do I solve for x? I got to square root this. So square root 707.42. I get 26.6. So x is 26.6. And I'm done. When you're good, flip your paper. Oh boy, last one, and then we get to practice. Secant theorem. Secant, I have one secant. Let me do this on a highlighter. And then I have another secant. When I have my secants, this is the formula you use. Outside piece times whole equals outside piece times whole. So if I look at my first secant line, I'm going to take the outside piece times the whole thing equals the other outside piece times the whole thing. So let's go ahead and look at some of these problems. Looking at the first one, notice I have secant. I have a secant line here, and I have a secant line here. So how I would set this up is I would do my outside piece, which is 4, times the whole thing, 6 plus 4, which is 10. And that's going to equal my outside piece of my other secant line, which is 2, times the whole thing, which is x plus 2. So now I'm going to clean all this up. 40 equals 2x plus 4. Subtract 4, I get 36 equals 2x. Equals 2x. So x should equal 18. Let's do the next one. Notice, is that secant secant? Nope, that's tangent secant. I have a tangent line here, and I have a secant line here. So I'm going to take my tangent, which is x, square it. That's going to equal my outside piece, which is 9, times the whole piece, which down here says it's 25. So 9 times 25, 225. How do I solve for x? Square root, square root. So x equals 15. Let's look at the next one. Keep in mind, all of this takes practice and memorization. That's all we can do. Next one. Hey, that's my party hat theorem. Here's a party hat. What do you know about party hats? Well, they're congruent. So I could say x squared plus 5 equals 21. So I'm not going to subtract 5 on both sides. I get 16. Square root, x equals 4. So I want you to take some time, and I want you to go through the rest of this notes sheet. The answers to this you can find on Google Classroom. If you want to work with the person sitting next to you, you're more than welcome to. But work through these next few problems and see if you can figure them out. All this does is it requires practice, so be patient and come see me if you have questions.